Moving on to the question number 7. Here we have two parts. The first part is explain the K-mean clustering algorithm with steps, discuss how initial centroid influence the results. Okay, so let's begin with K-mean, which is an unsupervised learning algorithm used to group data into clusters based on similarity, and each cluster is represented by a centroid, basically the mean point of that cluster. So steps of the K-mean algorithm would be first we have to choose the number of clusters. For example, k is equals to 2 or k is equals to 3. Then second step will be initialize centroids. We randomly pick k points from the data set and starting as starting centroids. Then in step 3, we assign each point to the nearest centroid. We use a distance matrix, usually Euclidean distance, or for deciding the which centroid each point is closest to. And the step 4, we update the centroids for each cluster. We take the mean of all points inside it, and this mean becomes the new centroid. And after step 4, after updating the centroid, we have step 5, where we repeat the step 3 and 4 until the algorithm converges. The convergence happen when the centroids stop changing or the cluster assignments remain the same. So that's the entire k-mean process. Yeah, and how initial centroid affects the results. So now here's something very important, that K-mean can give completely different results depending on the initial centroid chosen. So if the starting point are bad, K-means may form incorrect clusters or take longer to reach conversion, or can get and can also get stuck in local minima, meaning it find a solution but not the best one. So to avoid this, we usually run K-mean multiple times. So use K-mean plus plus, which selects better initial centroids. Now moving on to the question number 7th B part, we are demonstrate clustering plus computer KNN classification by example. So let's walk through a simple clustering example. Suppose we have four data points, A11, B2,1, C4,3, and D5,4. And we want to create two clusters. So we randomly choose C1 and C1, C2 as A and D. C1 is equals to A11 and C2 is equals to D54. Now we assign each point to the nearest centroid. So step 2 will be assigning the points. So A and B are closer to C1 and C and D are closer to C2. So we have cluster 1 A comma B and cluster 2 C comma D. The step 3 will be updating the centroids. So now calculated the new centroids will be 1.5 comma 1. Here we can see by from Euclidean distance formula, under root upon x2 minus x1 plus y2 minus y1. We will get 1.5 comma 1 updated will be 1.5 comma 1 first cluster, and the second cluster centroid will be 4.5 comma 5.3. So this completes the full iteration of k-means. So the claim in moving on to the part 2, KNN classification example. Now let's move to the KNN. Here we classify a new point, guess for P4, 2, and we have this label points 1, 1 as red, 2, 1 as red, and 4, 3 as blue, and 5, 3 as blue. So let's set the K at 3. So we calculate the equivalent distance from P to each point, and then C is the closest, I guess. C is the closest, and B and D are the next closest. So there are three nearest neighbors. So majority voting among the three neighbors would be blue is equals to 2 and red is equals to 1. The final prediction is that P4, 2 is blue class. So here's what we learned today. We learned about the K-mean group data by minimizing distance to centroids, and initialized centroids matter a lot in determining the final clusters. And we saw a complete example of clustering, and we performed a K-mean classification using distance calculation and majority using. So this was all about the question number 7, part A and part B. We have seen the claiming cluster algorithm and steps, and we have also seen an example for it. We have seen the clustering part and then KNN clustering part by Euclidean distance. Now moving on to the question number 8 in next video. So stay tuned and thank you so much.